Welcome to the Crazy Hat Chemist. So here we go once more. I can't wait. We're still doing stoichiometry and dimensional analysis. We're doing part 8.2 here today, stoichiometry with balanced equations. So we're going to do our second example with a balanced equation and stoichiometry. So here we go. Bam! So here's our problem. 0.567 moles of calcium chlorate is heated in a crucible in the absence of air. What is the mass in grams of gas produced? So this is our flow chart. We're always going to have our flow chart printed out. It's on my website. Okay, calcium chlorate. Calcium is a group 2 and chlorate is a polyatomic ion. You need to know the formula and its charge. You're going to take the 2 plus charge on the calcium, the 1 minus charge on the chlorate. Absolute value of those, flip, bring it down, and then you're going to get CaClO3 parentheses and a 2 outside. So calcium chlorate is heated up in a vacuum. That means that this stuff is going to be a solid. So, and I need a delta above the arrow. What type of reaction is this? That's your next question. It is a decomposition type of reaction. So again, what I want you to do is I want you to pause the video. I want you to write down the 2 products of this decomposition reaction. One of them is going to be a gas. The other one is going to be a different state of matter than a gas. Then I want you to balance it, and then I want you to restart the video again. So here we go. Bam! So you should see that calcium chlorate decomposes into oxygen gas. That is the gas. That's O2. It's diatomic. Remember, it's one of these. It's diatomic. It's a gas. And then calcium and chlorine are going to get together in their correct charge ratio. That's a calcium 2 plus charge, chloride 1 minus charge. Flip the numbers, bring them down, and you got CaCl2. That's also a solid. You're not looking at solubility rules on this problem whatsoever because there's nothing in here that is in solution. Okay, here we go. We're looking at our flow chart right there on the bottom. Okay, and we are starting off with calcium chlorate of 0.567 moles of it, in fact. What do we want? It says, what is the mass in grams of gas produced? So we're going to go to the O2. So we're going to go from the calcium chlorate all the way to the oxygen. Okay? And if I look at my flow chart there at the bottom, I have moles, and I'm going to get a mole ratio, and then I'm going to go to mass. So what I want you to do is I want you to set this up for yourself. You're going to start off with number units formula, and you're going to have a number units formula at every single step. So 0.567 moles of CaClO3 parentheses and a 2. That's what you're starting off with. What are the units in the denominator of the next term? Moles of calcium chlorate. What are the units in the numerator? Moles. What's the formula? Whatever it is that you want, and in this case it's oxygen, so O2 is going to go in the numerator. Then in the second term, in the second stoichiometric term, you're going to have moles of oxygen in the denominator, and then you want grams of oxygen in the numerator, and that would be the molar mass of O2. So pause the video if you didn't do it, and then do it, and then restart the video again. So here we go. Okay, this right here in my blue rectangular box is my mole ratio. Those are the stoichiometric coefficients from the balanced equation. That's a 1 in front of the calcium chlorate and a 3 in front of the oxygen. I am canceling out my units and formula of moles of calcium chlorate. And then I'm going to cancel out my units and formula of moles of oxygen. And I am left with units of grams and then formula of oxygen, and that's what the question is asking for. So, how many significant figures do I have on my starting number is 3. The leading 0 does not count. So the 5, the 6, and the 7 certainly do. How many significant figures in the 3 in front of the moles? That's infinite. Again, that's a counting number. How many significant figures in the 32.00? That would be 4, because those are trailing zeros. Trailing zeros count with a decimal, and there's a decimal in the number. How many significant figures in that 1? That's infinite. How many significant figures in that 1? Infinite. So the fewest number of significant figures I have is a 3 in this problem. Here's my number from my calculator. So I am using that 3 for rounding. That 3 is less than 5, therefore I truncate the number, and I'm going to have 54.4, and then units, grams, formula O2, and then I'm going to have number, units, formula, rounded correctly, and again, number, units, formula, every single time. Okay? That was the second video in our stoichiometric balanced equations problems. I can't wait for more. Bam!